Hello and welcome to the Swine Disease Reporting System. This is the report number 87 that we're going to cover the findings of April to 2025. My name is Guilherme Caesar here at the SDRS studio.
Hello, my name is Giovanni Travis. I'm from the SDRS team.
Hello, Daniel Linhares, also with the team.
And as I mentioned, we're going to cover the findings of April 2025 today. But before we start the podcast, I would like to introduce our guest for today. Today, we're going to have Dr. VanderWaal here joining the SDRS podcast. Dr. VanderWaal is an associate professor at the Department of Veterinary Population Medicine at the University of Minnesota. And Dr. VanderWaal has worked with swine virus for the past 10 years with her research focus on PRRS virus evolution, PRRS virus classification, molecular epidemiology, and also dynamics of pathogen spread through animal populations.
Cool.
Today, Dr. VanderWaal will explain more about the new PRRS virus 2 classification system and its implications of PRRS virus epidemiology. Welcome to the SDRS podcast, Dr. VanderWaal.
Thank you all. It's a pleasure to be here.
Excited to have you, Dr. VanderWaal. And Guilherme, let's walk over to the finds of the SDRS before I have this discussion with Dr. VanderWaal. What is the highlights for this month?
Well, Giovanni, let's start with PRRS virus, as always, our first pathogen in the SDRS report. And the positivity of PRRS virus is really high in the win-to market category. We are reaching 44% of positive submissions, which is not normal for April. Just for you to have an idea, look into the historical data. This is the highest positivity in April since 2018 that we are having this type of positivity. And at a state level monitoring, Minnesota and Iowa, when you look to overall positivity for these states, are having activity above the expected. And when it's good for us for highlight as well that, as was reported for the SDRS before and also for the ISU team, we were having a clonal expansion of the L1C.5. And this clonal expansion in this new classification that Dr. VanderWaal is going to talk to us later is related to the L1C.5.32 variant that is having a lot of cases this year. And when you look to compare with the L1C5, within all the variants in the L1C5, is 42% of the detection. So this never happened before. This year specifically, we are having a lot of detection for this specific variant. But according to our advisory group, so far with the cases that they are seeing, the virulence and also like the clinical impacts of this variant is kind of similar with all the other L1C.5. They're having severe clinical losses and also mortality in the field.
And that's not only the PCR positive, right? Do you have some information about the tissue diagnosis, what's happening there for PRRS?
Yeah, Giovanni, like when we look to the confirmed tissue diagnosis, only at the ASU VDL that we have this database, we are having a lot of cases that the diagnosticians are taking a look and see lesions for PRRS, like all of these above the expected for the last 2 weeks of April as well.
Well, looking for the yearly forecast, we are going to add summer, so we hope that that activity goes down in the next upcoming months. Any updates for the entire coronavirus?
Yeah, Giovanni, for entire coronavirus, also something that is not usual that's going on, like for PED and Delta, we are having a slight increase in the positivity of PCRs that are testing in vehicles in this specific month. And when we look for the cell farms for the first weeks of the April, we have an increased number of cases coming from several states. But the last 2 weeks of April, we start to get some positive cases in cell farms coming from Minnesota. So a typical activity for PED in cell farms for this specific month. And when we look to Delta coronavirus at the state level monitoring, when we look to the historical baseline, Indiana and also Missouri are having activity above expected for Delta coronavirus.
So something going on with PD that needs to be watched there. And how about other respiratory pathogens like Mycoplasma pneumoniae and influenza?
Yeah, Giovanni, like for going to influenza first, like as we talked in the last podcast, as always in the spring season, we start to have the spike in positivity in influenza and not different this year in the winter market and also South Farm. We have an increased positivity for this virus going on in April. And for Mycoplasma, they went to finish activity and increase a little bit the positivity. But when you look to the South Farm, remains stable. And we have a really good news that for the first quarter of the year, when we look to the confirmed tissue diagnosis again, from the ISU VDL, we have the lowest number of confirmed tissue diagnosis for Mycoplasma historically. So we are decreasing the number of Mycoplasma lesions evaluated by the diagnosticians when we see in the ISU VDL. And just to continue with the confirmed tissue diagnosis, as we mentioned, PRRS virus having some activity above the expected in this database as well. But when we look to cardiovascular cases, we are having more cases of Streptococcus suis and also Glasserella parasuis causing some pericarditis here at the ISU VDL.
Well, lots of activity going on there. At least mycoplasma is a good news there. Thank you for all of those highlights, Guilherme. Dr. VanderWaal, as you see, PRRS is still in your radar and causing problems there. And one of the things that has been uh, communicated and has been developed by your team was the PRRS variant classification. We also have implemented that on the SDRS dashboards, and on the SDRS Blast tool, you can find that information there. Can you explain for us and the audience how this system was created and what was the reasons behind doing that?
Thank you so much. I appreciate the opportunity to share some of this work with you. So I've been working in like the PRRS sphere for the past 9 or 10 years at this point, and one of the things that came up very early when I started to work on PRRS evolution is that RFLP typing was the main tool used to label or name viruses. And it's long been recognized by pretty much anyone who's ever touched a PRRS sequence that RFLP typing produces really inconsistent results about accurately telling you whether two viruses are related or not. And for a long time, it was say, well, this is the best we have. We don't have another tool to label viruses, so we are going to keep using RFLP types. And more recently, we started to ask the question, well, why can't we have something better? We have wonderful national scale sequence databases. SDRS is an example of one of those. The Morrison Swine Health Monitoring Project also has a national scale sequence database. And we have much better computational tools than we did 15 years ago. So about 3 or 4 years ago, we started a PRRS nomenclature working group that was underneath the umbrella of the AASV PRRS committee that basically tried to tackle this challenge of can we come up with a better naming system than RFLP typing. Lineages have been popularized relatively recently in, say, the last 5 years. They are useful in terms of actually grouping viruses into these kind of large ancestral groups. But the issue with lineages is they're still really big. So if you're sitting in Nebraska and you have a lineage 1H viruses, pretty much all your viruses are L1H, and it's not really telling you that much information when we get down to the farm level monitoring. And so we really needed something that's a little bit more fine scale than lineages and sublineages. And the system that we settled on was this lineage variant classification system. So essentially, this is an extension of the lineage system. It basically takes those lineages and creates smaller subgroups. And within a subgroup or within one of these variants, the OR5 sequences would be on average around 2.5% different from one another. So that's kind of what we expect for the within variant genetic distance. So relatively homologous, at least on OR5. It is an average. You will see, distances that are maybe closer to 5%. But typically, these variants are around 5% different from the most closely related variant. So that's the basic strategy of this classification system, and we've now fully rolled this out, and we have been updating it every quarter for the past 1 year, and we've been doing that with data that goes back all the way to 2015 in the US.
And a quick follow-up question is how can it be used in the field? Can you remind the audience some case uses of how this refined classification system is implemented?
Yeah, so one of the first things that we did when we started this working group is that we wanted to make sure that the system that we designed was tailored to the needs of the stakeholders and the clients that are actually generating the sequence data. PRRS is really unique. It's not like human diseases or many other diseases where sequencing really is mainly for, research or high level, national level surveillance. People are using sequence data very differently for PRRS, and that's really unique. So we conducted a survey where we asked practitioners to rank the top 4 reasons for which they were submitting samples for sequencing. And the things that came up as important was that they wanted to anticipate and track the spread of novel and emerging variants, determine the possible source of introduction to their farm. So this is kind of like an outbreak investigation scenario. and to discriminate between previous and new strains on the same farm. So we really designed the system and tested this system to answer those specific questions. And I think it works quite well for answering those questions. And particularly, it does far better at answering those types of questions than RFLP typing.
I see. And for those last two examples, is there a particular cutoff you like to use as a rule of thumb to determine if it's the same or not, or?
Yeah, so basically how this works is we have the national level sequence data set that we've defined the variants based on. And then we've built an algorithm that's available on our web tool, which is PRRSloom, but you can link to there from, I think, the SDRS website as well as the ISU PRRSview website. You can get to this classification tool. But basically, it'll run your sequence through and it will tell you your sequence belongs to this variant, right? And so if it's in that, if it's assigned to the same variant as a previous sequence on the same farm, or to maybe a neighboring farm, if you're doing an outbreak investigation, then you can start to narrow in, like, these are likely the same circulation event. Now, if it's labeled as a new variant, it gets a different ID than what you previously had, then it's likely a separate circulation event because these variants are fairly different. If they're receiving a different label, they're probably not closely related. And we check for new variants every 3 months as well to identify any groups that need to get their own label.
Thank you.
And that's awesome. And Dr. VanderWaal, as we mentioned in the SDRS highlights, we had like a clonal expansion going on, like this formation of the nucleate in the L1C.5 that later on in your new classification system for your group, we could see that was the L1C.5.32 variant, right? So can you explain to our audience like how these new names are assigned for each variant and like how these new variants emerge as well? And of course, like explanation about the clonal expansion, like what it is like and what is the implication for the field?
Yeah, so this new variant that you're talking about, this clonal expansion, is a great example of how this system is having the system in place is improving our ability to identify and respond to emerging new strains of the virus in the field. So this clonal expansion was identified as part of the variant 1C5 group, which is the formerly known as 1C144. That's the RFLP type that was assigned to this group. And it was actually initially flagged by ISU and the diagnostic team there as a group of interest. And we were immediately able to talk back and forth between University of Minnesota and ISU to identify what group is this virus and does it deserve a new variant ID. And in this case, on examination of the 1C5 sequences, this group of viruses is very large at this point. It's 40% of the sequences that we're seeing in the field right now, and there are offshoots of that group that are significantly different from the kind of original 1C5 variant. And so this clonal expansion is one of those offshoot groups that is 4 to 5% different than the original strain. And there's other ones too. So we actually made the decision to split the 1C5s and identify these offshoot groups. So there's about 7 of these offshoot groups that have now received their own label, including this clonal expansion, which is 1C532. You still will see the original 1C5 label in use, and that's because there are viruses out there that still look pretty similar to the original 1C5 group as well. So those viruses continue to receive kind of this parent label. As far as why we think this virus emerged, we don't know fully, and that's this having the system in place helps us identify and track, and helps us hopefully get down to where these came from. But for this one, I think that we're still investigating the origins of it. But what we can say is that it seems to be rapidly expanding, right? Viruses like PRRS kind of evolve with kind of a molecular clock, which means that they accrue these genetic changes in kind of a predictable rate. And what we see in a clonal expansion is we see a bunch of sequences that are all very, very similar. And it probably doesn't mean anything that the evolutionary rate is changing. What's happening is people are seeing that virus a lot and they're sequencing it a lot. So we see a bunch of viruses in a short period of time that are very, very similar, which basically is indicating to us that there's a rapid spread event going on. So we see that with the number of sequences, right? As well as that all of these sequences are very similar, which means that not a lot of time has happened in this transmission spreading event. So we can see signatures of these emergence events. We don't always know why that these viruses seem to be really fit and spread really widely very quickly.
Mm-hmm. From an evolutionary perspective, does it mean that if this clonal expansion is rapidly kind of, like you said, spreading, does it mean that it's just a better fit virus to the population, or is it too far to say that?
Yeah, I think in some cases it is because the virus is more fit. So we think about the initial emergence of these 1C5s. They spread really, really rapidly, and um, may have had features of that virus that make it more fit. Whether that's they're able to evade immunity from vaccines or whatever previously was circulating in those populations, or if they're just really good at replicating or anything like that, they may have these sort of fitness advantages. Also, it could just be kind of a luck of the draw, some sort of stochastic event that happens that allows it to spread between many farms really quickly. So, for example, getting into an area where maybe there's a lot of naive farms and it's able to just kind of roll through really quickly. So there's kind of these sort of random events that could also affect which viruses become, successful in terms of rapid spread.
Mm-hmm. No, thank you. I had another follow-up questions on coming back to the variants. When we look at Iowa here, for example, we see that it's typically we see about 60 different PRRS2 variants detected in any given year. So can you help us understand what does it mean and what are the implications? Does it mean to say that there are 60 distinct viruses going on, or how do we interpret those 60 variants?
Yeah, so Iowa and Minnesota, the upper Midwest is kind of the hot spot of PRRS diversity in the US.
Mm-hmm.
And you can see that in the SDRS data, but we can also see that in kind of the molecular epi that we do that kind of like all roads lead to Rome, right? All variants eventually end up in the Midwest because of the way we move pigs in this country. They're just highly likely, if they emerge somewhere else, to end up in the Midwest eventually. And yeah, I do think that if we're seeing these 60 variants, that means that we have 60 genetically distinct versions of the virus circulating. That doesn't mean that they all have a unique behavior and that there's no sort of immunological cross protection amongst these different variants, but they are distinct from a kind of their from a circulation standpoint, distinct circulation events. So what are the implications of this? Well, we know that farms, this is some of the work from your team, that farms that have infections by multiple different variants may have a more complicated picture for eliminating the virus from the farm. You have dynamics where some viruses maybe are underneath the surface and they're not detected for a while, but they're there, right? And so you get rid of the more prevalent one and then the other one comes up. So you can have prolonged closures, maybe more complicated clinical effects. And then from an evolution standpoint, if you have all this diversity circulating in the same area or the same farm, you have potential that some of those viruses are going to recombine. So these sort of recombination events, which could give rise to these new strains that are potentially have a different behavior than typical PRRS. So the 1C5 variant has a recombinant origin, and that could have contributed to why it has this highly transmissible phenotype that we observe with that virus.
And with the lineage system, we still don't know if it recombined from other regions, right? Because as you said, it's still based on that 4% of the genome, which is the R5.
Well, for the 1C5, we do have a lot of whole genome data. So we are able to see that it's a recombination, and it's a recombination event between the 1Cs, that lineage, and the lineage 1A, which is the lineage that includes all these RFLP type 174 viruses that are, were creating a lot of issues in the mid, 2010s. So it may have combined, some elements of both of those viruses and that produced that phenotype. But you're right, for most of the data that we have, most of these variants, we don't have whole genomes attached to every single one. And even if we did, we don't always know how to interpret that whole genome to say, is this, what does this mean for the phenotype of the virus, whether immunological behavior or the transmissibility of those viruses.
Mm-hmm. Yeah, well, putting Giovanni here on the spot, you mentioned recombinations, right? Giovanni, I think you put together with the AASV task force some guidelines on what can people do to prevent recombinations, right? And not sure if that would apply here to decrease that diversity too. If so, do you mind to remind us here the key points?
Yeah, the PRRS ESV task force has been very active in the last years, I don't know, decades already. And as Kim explained, all of this work from the variants, that was some work that born there and was a need for the industry. Also, this issue about, hey, what is next generation sequencing? What's the problem for recombination? Also was a discussion that arose in that committee there. So we assembled a work team there, and we did put together was two fact sheets at that time. One is explaining what is this thing about next generation sequencing. It's like a test tool, like a PCR, where you do the sequence of your sample and you expect to get a recovery of the full genome, like the PCR, you'd have a CT value there. So we explained that, and then the other thing was about recombination. It's a concept we know, personalized RNA, that is always has been recombination there. What has changed is, well, this next generation sequencing tool has been become more available, and the cost did reduce a lot, so people are using more of that. And now we have these bioinformatica capabilities to look into the recombination events that occur there. So we have the impression that that is being more frequent. Actually, I think it has not been detected in the past or has not been looked at as intense as we're looking for now. And then you start to ask them, hey, what's the implication of that? And it's like Kim mentioned, this lineage 1C.5 that is recombined between 1C and 1A really has been very aggressive. And those recombination between wild type strains is the ones that we need to take a look, because they has been causing a lot of problem in the US swine industry by this lineage 1C.5. Or if you look for PRRS1, the Rosalia in Europe is that also out there and causing problems. So it's a real thing, is a concept that's out there, but we need to really understand who are the problems, and that even that is the recombination between wild type and wild type virus there. So yes, there is those two fact sheets there that is available through the ASV that people can take a look in that and get more familiarized on those concepts there.
And that's it, guys, for the episode today that we had Dr. VanderWaal here. I would like to say thanks to her for her participation here. And she discussed about the PRRS nomenclature, also the implications of diversity, and also some explanation about clonal expansion. I hope you guys liked the episode and see you guys next time. Thank you.
Thank you.
Thank you.